Hello. Got something I'd like to share with y'all that I hope will be helpful for you. Subject is in the winter time on a heat pump. What should your temperature difference or your temperature rise? In the case of heating, you're rising the temperature. What should your temperature rise be? And I think that we have an industry that I'm going to say that almost everyone I've ever seen in the field, when it comes down to like a fall maintenance, they go and they're checking the heat on a heat pump. They'll just crank the thermostat up, way up, get it running. Yep, it's coming out hot, and that's it. More times than not, in my experience, my opinion, we've not been actually checking the heat pump without the electric heater's performance. And I would dare say that once you actually do start to check the heat pump without the electric heaters running, you will be shocked at how many are not performing well. I've got plenty of stories of my own homes where I've bared witness to this, customers' homes for sure, where when you really know how to measure it against what it should be, what it is doing, compare the two, and you realize, man, this thing is not heating worth a darn. So I'm going to go ahead and flip over to a little PowerPoint that I put together to share in a class recently on this subject. And the whole gist of it is to help you to understand how do you find out what the temperature difference or temperature rise should be. Okay, so I'm going to go ahead and switch over to this PowerPoint. And here we go. I'll go back to that picture real quick. That's about a 13-pound bass in the background. Okay, you get enough of that? Here we go. So now, the slideshow is, what's my should be temperature rise in heating for my heat pump? Most techs struggle with the answer. In order to find out what the temperature rise or should be, it's real easy. You need to know what document to look up. You think, since you're checking the temperature rise or temperature difference at the air handler, that it would be in the air handler manual, but it is not. It is located in a manual for the outdoor unit. That document is called a specification sheet. It's not the install instructions, it's the specifications sheet. So I've zoomed in on that spec sheet from the last slide, and you see where I've highlighted expanded heating data. Expanded means they're going to tell you what to expect from the heat at various different outdoor temperatures. As it gets colder outside, a heat pump's BTUs go down. As it gets hotter outside, the BTUs go up. It's a constant moving target. What do we expect from temperature rise on a heat pump? Okay, so I've gone to the expanded heating chart on the left. That's the whole page. And then I've separated it out and zoomed in on the chart that applies to my model number of my unit. Now, the general lay of the land is, if you look at the top of this slide on the right-hand side, okay, the right half of the page, there is a black line going across the top of the page that has outdoor ambient temperature. And then you notice from left to right, it may go 65, 60, 55, 50, 47, and so forth across the top. You have to tell this chart what your outdoor temperature is. Let's play make-believe. Let's say it was 47 degrees out, just so I can introduce you to the chart. If you were to come down below 47, 2 lines, and then go to the left, you will see the letters T/R. That's your temperature rise. You want to intersect the temperature rise line with the line coming vertically from 47, and it would tell you that, well, you should expect 28.4. So we're going to go ahead and do a little quick drill. Let's say it's 40 degrees outside temperature. That's the temperature of the air that your outdoor heat pump condenser has got moving through it. Okay, so it's 40 outside. I've circled it on the page so you know where to look. We're going to intersect the TR line and the 40 line together, and look at the 24.5 degrees. You see that circled in yellow where I intersected it? This is what's telling you what your temperature rise should be. Zooming in on it a little bit closer, once again, you can see here that this is your temperature rise. This is what you should expect from your unit. All right, so now you've got a method for checking. You've got to get the books out. Oh my God, not the books. That means every house you're going to go in, you're going to look up on Google Guide, you're going to open up a spec sheet, you're going to go to the manufacturer's app on your smartphone, a Lennox, a Goodman, a Cara, and you're going to look up the spec sheet on every heat pump. No, you're not. No one is. Let's be honest. But if I could give you a really simple, fast method that doesn't require you to do that, to figure out what a reasonable should be target temperature is, would you use it? That's the question. Would you use it? Okay, nobody is. You could be the one. You could be the one that starts to actually do something substantive for your, heat pump customers when you're doing a maintenance. Okay, and they're asking you, is my unit working right? You could actually be able to tell them if it's working right, but you got to know how to figure out what the target is. So here we go. There's a really good rule of thumb that you can follow. Okay, now I want to say something real quick about rules of thumb. I don't like ballpark answers, rules of thumb, Bubba and Skeeter's cheat sheet. I don't like things like that horrible 20-degree cooling split garbage that the industry uses. Well, my split ought to be about 20 degrees in coolant. That's the most horribly wrong junk that there ever was. Because it might be that, depending on the wet bulb going in the return, that you might only should expect a 10, 11, or 12 degree split on a real crazy humid day, right? So 20 degree was junk. But this rule of thumb I'm going to share with you on heat pumps to get a heating target temperature rise, okay, what it should be, is really pretty reliable. And certainly better than what? Nobody's checking them. So let's start checking them with a ballpark rule that's not even a ballpark rule. It's a really good rule. And it's called the 32-20 rule. So 32-20 was shared with me. I didn't come up with this. I keep saying I use, but it's because I use it with confidence. And it was taught to me by a gentleman named Rob Cummings up in Nashville at Dale Supply Company. And this man was super bright. He was the technical service rep for the distributor that I taught at for 4 years up there, and he was so sharp that Nordine would call him to ask for help. Here we were, Nordine dealers or distributors, and they would the smart guys would call him. So I can tell you that I have faith in this. I've bared witness to it being accurate, really accurate enough for us to use to go ahead and say, I'm on a maintenance, it's 55 degrees outside, it's 60 degrees outside, what should my heat pump split be without the electric heaters on? Okay, so feel free to go look up the spec sheets every time and not use this, but this is a whole lot easier way. I'm sort of lazy, so let me share it with you. Okay, the general premise is, when it is 32 degrees outdoor temperature, you should expect a temperature difference of about 20 degrees. Now, we give ourselves some fudge factor, and I don't really like this fudge factor, but we're going to do it. We're going to say plus or minus 5 degrees. People go, well, you should just use the spec sheet. It's accurate. I'm going to tell you right now, yeah, from 15 to 25 degrees is a big spread in this example. Okay, I get it. But you know what it's being compared against? Zero, nothing. Nobody is even thinking about heat pump performance. So I'm going to get you this 32-20 rule. Y'all start doing it, and if you want to get a spec sheet out every time to get the actual stuff out of the book, go ahead. But you're going to find every time you compare this 32-20 against it, it's pretty darn accurate. Okay, so here we go. Let's test it out. Let's look at the chart and find the closest reading to 32 degree outdoor temperature. Go down to the TR line. What is the expected? Okay, in other words, what is the should be temperature rise? See where I've highlighted under the 30? I came down and then I went to the left to TR. You see where they intersect in the circle? You see that 19.8 degrees? That means that this manufacturer says when it's 30 out, their heat pump should produce 19.8 degrees of temperature rise. Now, 3220, well, at 32 degrees, we expect a 20-degree split. 32 is 2 more degrees than the 30 column, and 20 is just a little bit warmer than the 19.8. The warmer it gets outside, the more heat we get. I'd say 3220 was pretty darn close in this example. So let's use 3220 method and calculate a should-be temperature rise for a 55-degree day. You're there. Let's set the stage. They called in and said, my heat wasn't working real good last night. And I'm going to tell you, me as a tech, I'm going to go ahead and follow the method I'm sharing with you here. I'm going to put the unit into, I'm going to force it into heat. I'll start in cool and then manually switch the reversing valve. This way I have nothing calling the electric heaters on. I want to evaluate my heat pump's performance just as a heat pump. Okay, so we're going to say it's 55 degrees out. This sheet right here, start at the top left, see the number 2. To the right of that, it says outdoor temperature. To the right of that is a vertical line separating the left page, that's your outdoor temperature side of the page, from your right page. That's your should-be temperature rise side of the page. You see that 1? That means for every 2 degrees outdoor, you get 1 degree of temperature rise change on the right side of the page. All right, so let's go to the next one. Y'all ought to go ahead and pause this video, screenshot, take a picture of this, go ahead and if you screenshot it on an iPad or whatever, if you're watching it on that, you can go ahead and print these off and put them in your textbooks, and they can be a little worksheet for them. And whenever they get to a house, they can start practicing this. So we said it was 55 out. I wrote that 55 above the 32. If it were 20 degrees out, if it was something less than 32, I put it below the 32. Just saying. Subtract 55 and 32, get the difference. It's 23. Easy peasy. For every 2 degrees on the left, you get 1 on the right. So divide your 23 by 2, and you will see that you have a 11.5 degree difference. Okay, since 55 is warmer than 32, we're going to add that 11.5. If we had a temperature that wasn't 55 but rather something colder than 32, we would take the difference, divide it by the 2, and then subtract it from the 20 to get our should-be temperature difference. So this is what it looks like. We're warmer out. We're going to add 11.5. We've now got a target using the 3220 rule of 31.5 degrees. That's what it should be, okay? Remember, I use plus or minus 5, good enough to say that we're at least checking something to see are we close. My God, let's at least do that. So now let's compare that 3220 method result of 31.5 against the chart at 55 degrees. And if you take and find 55 at the top of the chart, come down, intersect the TR line, do you see where I've circled 32.2? Okay, well, that's that manufacturer. That's their smart, smart engineers, all them folks, with that specific equipment, the way it's constructed, they have spec'd out to us that we should expect 32.2 degrees. And I came up with 31.5. My God, isn't that close? And I didn't have to go get a book. 3220 rule works pretty good. Remember, once again, plus or minus 5 degrees. That will help us handle the fact that some air handlers have bigger coils than others. Some of them might move a little less or a little more air. It's set a bench line for you to judge the equipment by when no one's really judging anyone's heat pump performance at all. Let's start doing it. So here's some ground rules. The 3220 method is intended to be a quick, simple method, but it doesn't replace using the specifications document for the heat pump condenser. All right, so remember that. All right, the real answer comes from the spec sheet, but who wants to go looking those up every time? Number 2, do not run the electric heat while testing the heating split, the heating temperature rise. Easy way to do this is start the unit in cooling. On excuse me, on O reversing valves, Corona, On O reversing valves, disconnect the orange wire. Remember, you started in cooling. And here's how this goes. Miss Jones, we're going to go ahead and check your heat. The best way I can check your heat today is to make the house a little bit cool. I need to do this to truly test the heating performance. So if it gets too cool for you, please don't turn the thermostat or off or adjust it. I'm in the middle of testing. Just throw a sweater on for a moment. I really want to make sure it does a good job of heating for you when it does get cold. That's what I say in every house. It's pretty easy. Not many customers are gonna have that big of a deal if you explain it right. So I've put the unit into cooling on the thermostat. That doesn't turn on the electric heat, does it? It's in cooling. That's what I want. So now I go to the outdoor unit. I'm trying to get this unit to stabilize for a while. The unit's running. It's in cooling. Okay. I may even get a job link report on that. People will say, well, if it's cool out, your readings don't mean a lot. Yeah, I could spot a 30-degree superheat on a TXV as a problem on that report. Just saying. But this video is not about cooling interpretation. It's all about, figuring out your split, what it should be on the heat pump heating. Okay, so I go to the outdoor unit. It's in cooling, and I undo the orange wire for the O reversing valve units. Whoosh, round, 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 round. Unit switches to heat. Now I'm going to go ahead and I'm going to run it and stabilize the unit. It may take 10, 15, maybe even 20 minutes depending on how cold it is. And what you're really waiting on is to make sure that the unit will, the temperature rise doesn't keep changing a lot. When you first switch it over, it's going to be like, you'll watch your temperature rise, your delta T, if you will, and you'll see it bump, 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 bump. It's going to change pretty fast as you go into heating mode. But then it's going to get to a point where bump, 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 bump. It's not changing. The numbers aren't changing much anymore. I'll call that stable, okay? Ultimately, you want to make sure there is no more ice on the accumulator. If they have an accumulator and there's ice on that accumulator, it is going to cause the suction vapors going into the compressor to overcool the compressor. And that means that the discharge temperature that comes out of your compressor is going to be much colder. That's the source of your heat. If you are judging the performance of a unit while there's ice on the accumulator and it's overcooling the compressor's not going to produce much heat. So we need to stabilize the unit. Once you see that it stops changing a whole bunch, don't you're looking at your temperature rise on your job link or on whatever app you're using, you're probably stable. If you can put a flashlight on that accumulator, just make sure there's no ice on the accumulator anymore. Now you're ready to go get your actual temperature difference, your temperature rise, and write down what it is. Next, if your actual temperature, what it is, if what it is within plus or minus 5 degrees of the should be target that you figured out with 3220, we call it good. If not, the first thing you should do is verify what the specification document says it should be. So use 3220. It's real easy. You got to get a book out. But if it's out of what 3220 says it should be, then go look it up and verify it on the specification sheet. I think you'll be pleasantly surprised. High 90% of the time, 3220 is going to put you on a number that is certainly within, the plus or minus 5 of the target listed in the specification sheet. Remember, folks, just because it's not perfect, just because 3220 is not 100% accurate 100% of the time, it's high 90%, and it is something where people were doing nothing. Okay, number 5. Both the specification sheet and 3220 method are what you should expect. The should be is what you should expect in temperature rise on a unit moving 400 CFM per ton. And I tie it again, plus or minus 5 degrees. If it's warmer than it should be, okay, more times than not, you're not moving enough air. But if it's within 5 degrees of the target, I'm going to live with it. If you're cooler than what it should be, it could be that you're moving 450 CFM per ton, okay? So I hope I said that first one right. Higher temperature means lower airflow. Lower temperature rise means higher airflow, or something else is going on in your system. We won't get into that right now. I just want you to be able to tell us, guys, on a maintenance, is your unit producing? And if not, let's call in the service manager and get a service tech out there. This PowerPoint was not intended to teach you how to troubleshoot. I'll do another video and share a few things that I've been taught that may be helpful for you in the very next video. Okay. So last note, there are some ARI matchups that place very large indoor coils into a marriage with smaller outdoor heat pumps. One good example is I have a carrier here in my training center. It is a 4-ton air handler, but when you look at its board, that air handler can be tuned all the way down to 2.5 tons of airflow. That very same air handler can be married all the way to a 2.5 ton condenser. So you can only imagine with a massive coil like that, that it may screw with what we expect from a temperature difference out of that unit. And it's in those weird matchups that if you look up in their spec sheet, well, man, that's 6 degrees different than your 3220 thing, Alan. Oh my God. Yeah, all right, I'll give you that. But more times than not, a 3220 will work well for you. I must say this. I use 3220 on all systems, okay, on single stage, on 2-stage, and I'll even use it in test mode, okay, test mode on inverters. So inverter systems are a different animal, okay. You don't just crank the stat up, you don't go screwing with reversing valves, okay. You literally, like on Linux, you would go to the stat and put it in test mode, and you select that you want only the heat pump and no electric heat. It's not a go mess with the reversing valve thing outside. It's more sophisticated. So let's just stick with the premise of most of the systems, single stage, 2-stage, non-communicating units, okay? Actually, you could probably get away with uncommunicating, but let's say non-communicating units. A lion's share of what's out there on the ground, you can use this method to go ahead and check them out. All right, so the 3220 rule might yield a very different 6 degree or more from the actual spec sheets listed temperaturized. No sweat, like I said above, when your 3220 is real different from the actual, the is temperature, look it up in the spec sheet. Done. Okay, next thing. If you've looked up in the spec sheet and you're still way off, more than 5 from the spec sheet, you got to be able to troubleshoot, and that's a whole other class. That's a whole other deal. But you've just identified there was a need. Oh my God, thank you for checking me, Mr. Tech. I have a problem. And you should be going ahead and moving on to that next level of troubleshooting. This presentation is not going to talk about troubleshooting, but rather just illuminate that many techs don't and need to check the heat pump's performance during services. I hope that it's been helpful for you. Let's be honest here. Not many techs ever unhook or defeat the electric heat to actually test the heat pump's real heating performance. And if you actually do it, you'll be surprised how many are not performing correctly and asking you, the units are asking you, they're begging you to pay attention to it, and nobody is. I hope this begins your journey of actually testing heat pumps this fall and winter. Go do it. See ya.